So you want to travel to Mars. You love the idea of interplanetary space travel and would love to be a spacefaring individual who will sail across to the moon, to Mars and beyond. Well, in this video, you'll get to know everything you need to know and watch out for before becoming that type 2 civilized species you've always wanted to be. To start with, a trip to Mars is a long one which takes about 7 to 9 months on average. Also, Martian atmosphere is relatively very thin as compared to that of Earth, and so when your spacecraft is entering into the Martian atmosphere, it will experience an atmospheric drag that is not sufficient to slow it down as it descends. And this means that your spacecraft will require the use of heat shields, parachutes, and even retro rockets, which will provide supersonic retro propulsion that will sufficiently slow down the descending spacecraft to a good halt. Okay, now you've successfully landed your spacecraft on Mars. Well, before you hop down, you've got to know a few things. Mars has a really weak global magnetic field, which if strong like on Earth, will be used to protect itself from galactic cosmic radiation and solar radiation. As Mars' magnetosphere weakened around 4 billion years ago, Mars' atmosphere was stripped into space by solar wind over the next 500 million years, and currently there's an increased risk of cancer and radiation sickness on Mars. Alright, so where do you live then? Currently, the best place for you to stay on Mars is inside a lava tube. Mars was once Earth-like and was geologically active around 4.2 billion years ago, and these tubes formed when molten lava flowed underground, creating tunnels whose rocks solidified over time. We won't want to live above the ground now, as current building plans, including Martian regolith's proposed habitats, have not been tested to provide adequate protection against the radiation on Mars. These tubes, however, have thick walls which protect you from intense doses of radiation. So way before the first astronauts land on Mars, robots will be sent to help you with locating and making these tubes habitable. Okay, let's look at the basic human requirements. We currently can't find liquid water on Mars. However, there are ground ice near the surface. Due to the extreme costs of transport, you've got to get water and food locally on Mars. To get water, you would use a Rodriguez well, commonly known as a rod well, which uses heated water to melt ice into liquid water in simple terms. This will generate water that contains perchlorate, which needs to be treated before any reasonable use though. And for food, you will need to adopt a hydroponics system as opposed to using Martian soil, as it also contains perchlorate, which will require large amounts of water to be removed. Also, the water from hydroponics can be sterilized and used again in growing crops, including soys, peas, wheats, etc., which are good plant-based meat substitutes. However, this will require some energy investment into artificial lighting due to the lack of sunlight in the tubes. Moving on, Martian air contains majorly carbon dioxide and just a bare 0.13% oxygen, as compared to a whopping 21% oxygen in Earth's air. So what do you do? Well, NASA has developed something called MOXIE, which is Mass Oxygen In Situ Resource Utilization Experiment. The device with this technology will help you make oxygen from carbon dioxide, so you'll be just fine. But how do you power this MOXIE and all other electrical devices in your habitat? Here is where solar panels come to play. An array of solar panels will be installed on the Martian surface, which will however harness just 40% of what we harness on Earth. But Mars has windstorms and the dust are electrostatically charged, making them sticky to surfaces, right? Well, to protect our solar panels from being clouded with fine dust particles, I propose a system of IoT-controlled coverings for each of these panels. SDG STEM kits with dust sensors fixed on the panels will continually read dust levels, and when they reach a predetermined threshold, coverings will be deployed automatically on the panels in the style of a camera shutter, and the panels will remain covered until the sensor gives instructions to open up. Well, now that we have talked about IoT, let's look at how you can implement IoT to make your habitat better suited for you. To provide adequate pressure and enclosure, you will need to fit in a network of inflatable pods inside the tube. Inside the pods, you will need a STEM kit with attached Geiger counter, barometer, seismometer, VOC and ECO2 gas sensor, and flame IR sensor. On the surface outside the tube, you will need an ESP32 camera module and an anemometer X chip attached to a fixed STEM kit. So there you go, young Martian, there's nothing much after all. Remember to implement circular economy, and when you're ready to come back, use electrolysis of water in making rocket fuel. See you on Earth by 2025. Goodbye.